That means. Yeah.
I did 2 different.
Oh my God, my hair flew away. Oh my God, I love my.
Oh, no, you need to turn in your lab safety contract, sorry.
Oh.
Yeah, you need to turn in your lab safety contract, I'm gonna check your measurables, work, there you go.
No problem.
True blue.
Keep your service.
I haven't turned this in yet, but I haven't. Huh?
Excuse me. I really don't want to move anywhere around.
Well, you know.
Everybody's sick.
Complex out? The live streams? Set up.
Good thing you didn't like convert like 1 foot to inches, you know?
I did my eye. Nobody did that.
Nah, I got it.
Yeah, actually.
Oh, cool.
Yeah.
I'll let you know. Got dogs.
At least I did mine.
I feel like that other state's thing.
I know,
Something about rolling houses or
I
something.
see me.
Roll trees. Isn't that ironic? They're so
Didn't it like poison someone's tree? Or is that their
That
school?
was Alabama.
You're probably about to call me by. You're probably about to call me by my middle name.
More than you.
Just let them see it.
You're about to call me by my middle name.
Just let them look at it.
You can just look at it for yourself.
How about I just look at it?
You can.
I mean, you know what? Solution. Let me look.
Good job,
Bottom,
Emma.
bottom.
Thanks, dude, I feel like I did all these graphs wrong.
Is on its way. It's just
I always got
on
it.
its way. Why didn't you do any more?
But you know, it is what it is, and you know, it's it'll be okay.
Look at the last one.
Hold on, let me look.
I messed up.
Let me later. Okay, what's on the back?
I didn't apologize to Matt, so I apologize
Okay, what's the other sheet?
Apologize to future users.
Okay, maybe I didn't do it wrong. He didn't show us what that looked like. You don't even know. I don't remember.
No, he like did all this in the video. But we had to graph it in the
I don't remember that.
Carly?
Like, this is kind of I did put that No.
All multiply and all lengths. There's 5 things. They're just all lengths.
No, I want to go.
What do you mean?
It was on the same subject as he said. What do you say?
This was it.
I
didn't actually.
You said you teach yourself, and you were like, why? Yeah, for your future grade.
You just don't put anything in the bag.
I guess.
The answer is put off the side. You plug it in the conversion factor.
I mean, that's not even that bad.
And your purple page of the regular book has that information. All right. Just data sometimes delay your visits to the office. Sometimes.
But I had to get this fixed because it was like my entire class.
I thought Miss Knight should go for the national championship.
This was a new thing.
I'll go. Okay, so would you like to see some more conversions?
Yes.
Yes, sir.
Okay. Who was one of you with the multi-step ones?
Definitely not me.
Definitely not.
Okay, Warren. Give me a start point, Warren.
I did 8 yards to inches.
8 yards to inches.
So that wasn't
That wasn't the most? Alright, let's do 8 yards to inches real quick. Let's just do it, and then we'll do another one. What was your hardest one?
I mean, I had other hard ones that were like more converting, but it was just one step.
Gotcha. More converting, but only one step? Was this one multiple step?
Like it was confusing.
It was just wasn't even on both.
It just, yeah, it's not. It's like decimals.
All right, 8 yards to inches. Step 1.
Yards to feet.
Step 1.
T-charge.
Step 2.
Take what's given.
Give it in the upper left.
We got 8.
Okay. Step 3.
Units asked for in the upper right.
Hey, Kush.
Inches. Ooh. So maybe you can, but can you go straight to inches? Do you know? Can I go straight to inches? You may not, but let's just pretend we don't. How many? What can you go from
3 feet.
yards into feet? You go into feet, and then could you go into inches next?
Yes.
Yes.
Therefore, I just took a double course helping of step 3, units asked for in the upper right. I did a unit I know I can go to, which can allow me to go to the units asked for. Are you with me?
Oh, I just did
I took a unit I can go to in order to go to the units asked for all along the upper rights. Hello?
Hello.
Okay. Then I'm going to do step 4 twice. 2 times. I gotta stop whispering for the at-home viewers. What?
Who's you at home?
And
Where's she?
she got COVID.
She has it?
Okay, okay, stop. We don't need this. We need it. Drag down units from the given. So, yards and feet. Now you're set up. You took like the thinking's done. Now let's go look at a reference page with your conversion factors on it. Which these conversion factors are not a big deal. What was 8 yards that was in your life?
I just like thought about it. I didn't have it in my life.
You're like, I had to pass 8 yards as I got to my house. And I thought, you're
Maybe
gonna
my
measure
driveway.
8 yards. Hey, I could convert that. Or were you just sitting like, let me think of a number?
Yeah, I did that. That's what I did.
The second one?
Yeah. Just a number. And then I was like, 8. 8 would be
Sad.
great. And then I was like,
8 is great because it has 2 circles.
So then we can do conversion factors. How many feet are a yard? 3 feet, 1 yard. 12 inches, 1 foot. A lot of y'all did good old multiplication. Make sure you guaranteed it. It's fine. Just, I expect a little bit more from Gifted Honors, maybe.
Where's your man?
Shots fired, I know. Eek.
We're definitely the disappointment of the honors classes.
Disappointing?
We're one of the disappointing honors classes you have.
You're the only one I'm teaching right now.
Well, that
so-
last semester probably way better.
Again,
It had a lot of.
we're talking about one assignment, and I'm not saying the whole assignment. I'm just saying
I did it.
in general. Did anyone do any multi-step where you had to divide and multiply at the same time?
Whoa.
Like in the whole
I did
thing?
more united, but it's not multi-step.
I don't know.
Did the people in your other?
You did a speed one?
I didn't
Okay. Okay, good. Well, good. Okay, good. I'm not fully disappointed. I'm only part disappointed. And I wouldn't say disappointed is even. I'm not ready to use the word disappointed yet. Anyway, I'll go.
Man.
VR setup. We can see cancelable are these. Uh-oh, let me check my feet over here. Make sure I'm in the corner. We can cancel the units that are on top and bottom, which leaves us with 8 times 3 times 12 inches. And I'm not going to go further than that, that's all. What is, let me get a speed one.
62 miles per hour, meters per second.
It's on a country road? It's too fast.
I was in a 45.
Wow. Y'all just not too much. Tell me about it. To what'd you convert to?
Meters per second.
Oh, meters per second. Good. All right, and so step 1.
T-charge.
Step 2.
Give the units in the upper left.
Miles per.
Per.
Hours goes on the bottom, 1 hour. Yes?
Yeah.
So then we have it a rates conversion, so miles to meters, and then hours to seconds can be basically independent of one another. Miles is up top, so meters will go up top. So the conversion will take place up top, on the top part of the T-chart. Whereas hours is going to convert to seconds along
The
the
bottom.
side. Nope,
Oh.
the bottom. Along the bottom.
Oh, okay.
That's just like, where else could it go?
Oh.
Not the side. It doesn't make any sense.
That's why I was confused. It's not a side.
Okay, so I do have steps over here for that matter, for what I'm referring to when we say these steps. Step 1, T-chart. Step 2, given the upper left, etc., etc. That is over there. Okay? Just in case you're not following, you didn't pick up on it yesterday, or in case you weren't here yesterday. Okay, thanks. Let's keep going. 62 miles. Can I go from miles to meters direct? Not and be precise and accurate. So we got to go in steps to the most precise and accurate conversion factor, which is centimeters to inches, or vice versa. Hello?
Hello.
Do you remember writing that conversion factor yesterday?
Yeah.
Centimeters and inches?
Yeah, got it.
Those are two
I think I
quantity
got it.
relationships.
We'll put zeros.
2.54. Okay, I just wanted to see if I heard someone mumble it or say it aloud. Good. We're good. You did get it. So miles, we can't go miles directly to meters, but what can we go to? Feet. And then I can turn that into inches. And then to centimeters. And then to meters. Those are all steps I can take. And now I have the asked for units in the upper right. Or the top asked for units in the upper right. Step 4 is drag, so do subsequent drags. Miles, feet, inches, centimeters, 52, 80. That doesn't hit as hard as it did yesterday, does it? 1 foot, 12 inches, 2.54, 1 inch, 100 centimeters, and 1 meter. What say you? Are you lost? Are you fine?
Yep.
Okay. Okay. And then that will get the job done for meters up top because, check this out. We have miles up top and on bottom. Feet up top and bottom. Inches, centimeters, we're left with meters, check, on top. Now all that's left is the bottom part, which is seconds. That's what we want. And then the drag becomes an opposite exercise. 1 hour, 3,600 seconds. For cancellation purposes, gonna see it done. It probably bothers some of you that I just did this, the cross out slash, the opposite direction of the original one. Anyone bothered by that?
I didn't even notice that you said it. There's.
It's interesting, people, you know, you people. Anyway, let's keep going. Go Dogs. I would have noticed something like that if I was in your seat, you know what I mean? So.
Well, why? Who slashes that way to begin with? Unless you're like left-handed. I mean, that's kind of
I really didn't even know, like, the urge just came upon me and I just followed.
Yeah, I think that's kind of weird in general. You do it that way. Because you want this, that way.
I can't even say that it was convenient per se. I just did it.
Yeah, because it's definitely inconvenient. You just like go the opposite direction.
Inconvenient. But anyway, let's keep going here. 62 times 5280 times 12 times 2.54. Then divide by the bottom set. Are we okay? Oh, we're good?
So could we also like just make a whole other T-chart with it all on, which you kind of did, it's just unconnected. But
So
like,
you
it's
wanna
like
go
a
like this?
separate quantity. So it's like a separate thing to do a separate T-chart and combine the two informations. So basically just take that last little box and just create it while you just figure out the bottom part of it. Just figure
So you want to do the top part and then rewrite and then do the bottom only.
For some reason, yeah.
Okay. I would say here's why I would not do that. It's because you're maybe unlikely to remember that you're now, when you first do the top, you're now in meters per hour. So then your units in meters per hour, which you have to convert into meters per second on a separate chart. And if you don't bring that whole value as a meter per hour, you may be prone to like just get mixed up.
Okay, yeah.
I just think this lays it out as a plan, and it may seem a little bit of an uphill climb for you to figure out how to make this method your own, but the method is
Gotcha, okay.
it's like a background running icon.
So will we have that purple sheet on test, or we need to know the things on that?
You'll have the purple sheet on tests. You'll have the conversion factor on test. Yep. All right, and then you multiply the top, divide by the bottom. All the bottom needs to multiply first because they're all separated by vertical lines, which represents multiplication. So be careful there. That's a place where you can miss, but I don't want to spend too much on that. What about, did anyone take volumes and convert?
No, sir, I did not.
What, like,
Milliliters to what?
fluid ounces, or fluid ounces, milliliters?
What about milliliters to cubic feet?
Whoa.
I don't know, maybe you just thought it was a challenge you could
Well,
do.
do that.
Why wouldn't an overachiever do that? I'm saying.
Oh, you're those people.
I'm saying you could raise the bar and challenge yourself and go above. Or, as the walrus would say, you could just not. You know? Just settle. Or, well, let's keep going. So what about rooted dimensional analysis? Oh, this has been dimensional analysis. What about roots? Like square meters and cubic feet and square inches. Eesh. What aboutism? Let's take an example right here, 11.6 inches, and let's go to cubic. Let's scrap that number. I'm gonna change it. Change my mind right now. Let's do 7.9. Yeah, 7.9 cubic feet, square feet, excuse me, and let's convert it to square meters. Square feet. I said cubic. I then corrected it immediately, but yeah. Square feet to square meters. Hello?
Hello.
That's a 9. That's my force. Just to teach you what my force is like. My force will never be that 4. I know some people, not me. It's not this people. This people do this.
You have a problem with my force?
This people does this. Okay. That's it. That's all there. Just so you know, I'm just educating you on how I do force.
Oh, thank you.
And now you might remember that forever. All right. 7.9. Step 1.
T-chart.
T-chart.
Everything pretty much follows the same text. 7.9 square feet. T-chart. Second, given in the upper left. Step 3.
Use ask for the upper right.
Ask for units in the upper right. Okay, so what I ask you to do is put little blinders on a little bit. Pretend, for the purposes of filling out the rest of the T-chart, you don't see the square. Can you go straight from feet to meters? No, but what can you turn feet into? Inches. And then inches into? Centimeters. And then centimeters into? Meters. Those are things you can do. So go ahead and finish what you can do. Feet. Inches. Centimeters. Step 4, drag down. And it would be at this step where you'd run into perhaps where you're like, this doesn't seem like it should be this way because I started out with square feet, and this method so far is all about linear, not volumes or 2 dimensions. So there should be something else to do. And you drag down feet square. You didn't drag down feet square. You drag down feet. That's okay. The drag down is to set you up to plug in a conversion factor that you know. So let's just go ahead and get to that point. Just plow through a little bit. The method is essentially pretend the square is not there for a moment. Finish through step 5. This is it. One modification, and then you'll see the modification come soon. Are you there?
Yeah.
Are you still bearing with me? Have I lost you? Is there anyone have a question about where we are in this stream? Okay, good. So then we just fill out the conversion factors. Okay, neat. And now we got to rectify the square situation. we're at a point where we need to calculate. We need to calculate with the right numbers. And right now, we're not going to do it. Let me just paint the picture for you gifted honors folks, just from a units. Let me just look at the units here. If we just look at units here, our final units at this point would be a foot meter, which sounds like something like a circus or a fair or something, to measure the size of your foot, I guess, or weight of your foot. I don't know. Anyway, that's not a real unit. That certainly doesn't answer the question of meters squared. That's a foot meter. It's not meters squared. Hello? Are you there? So of course it's obvious to you that there's something else to be done. Well, when we cancel out here, actually let's see. When we cancel out here, you see what is being done. What is necessary to finish the canceling? Huh? Square root? What's the opposite of that? Square. What is squaring? What do you mean by squaring? What could you mean by squaring?
We need to put square.
What do you? Okay, multiply what by itself? What number? Try all. Try all.
Everything.
So watch this. In order to cancel out feet, I would need to multiply by another feet on the bottom. Are you with me? If I were to multiply by another feet on the bottom, that would be feet squared, so feet squared you cancel with feet squared. If I were to multiply, this feet came here only when this inches came. So if I squared this feet, I'd have to square the inches. In which case I'd have to have square inches there and square centimeters here. And square centimeters here and square centimeters there, which will allow everything else to cancel except for square meters, which would solve my conundrum.
Does the square, does it carry to the number too, or just the?
Well, hold on. So we're just deducing. We're stepwise deducing what's a strategy we could use mathematically. Our issue was when we started to cancel. When we just look at the units and start canceling the units don't cancel out the right way. It doesn't work, right? So we need another method. Well, where did the cancellation issue arise? It arose in this step. I had 1 foot cancel with only the 2 upstairs. Hello?
Hello.
Does everyone see what I'm saying right now? It was feet squared. I had 1 foot unit on the bottom. 1 foot unit cancels with only the 1 of the 2 feet squared. Are you there? So that was where our issue happened. In order to fix it, we would need to have feet squared on the bottom. But remember, we were only able to drag down feet here because we had an inch up top. So if feet are squared, then inches must be squared. And if inches were squared there, they must be squared here. So centimeters would need to be squared, and therefore squared, and therefore squared, which then puts us in the units we would like. So all of that helps us point to the strategy. We need to square every step. We need to square the inches to feet step, this step, and the last step. Avi.
Is it the same thing as with the tiny tube?
I'm sorry?
Is it the same thing as what we're doing forward with a tiny tube?
Yeah. Sort of. Okay, and so how does that play out here? What does that mean? What do you mean? Huh? What do you, like, be specific about one example.
Like 12 inches needs to be squared.
Okay, but if you do 12 inches, you're saying 12 inches squared still equals 1 foot? So what is this whole column representative of? Step 5 CFs? What is it? It's a conversion factor. So what's the strategy? Square the conversion factors. Square the conversion factors. Wherever there needs to be cancellation. So we square this one. We square this one. We square that one. everything gets the square.
Number 2.
Numbers too. Because when you square anything, the square goes to everything. It goes 12 squared, inches squared, foot 1 squared, foot squared. Let me demonstrate. I wrote it out in the other class too. Except for they did. I'll just do it because y'all have different problems. Shouldn't have done a different problem. That's what I get. I'm trying to overachieve right here. Feet squared, 12 squared, inches squared, feet squared, 1 squared. Centimeters, 2.54 squared, centimeters squared, 1 squared, inches squared, 1 squared, meters squared, centimeters squared, 100 squared. The squared goes to everything. Hello?
Hey,
That's just the nature. That's an algebra problem though. So if you have an issue understanding why the squared is distributed to everything inside of a parentheses or to everything that it squares, that'd be another haul over, I believe. We can work on it 301, but it's a 301 discussion, not an in class. Because I think you got it. I think you should know it. Am I wrong? Let me peel back the curve a little bit. Have y'all seen that before? Squareds distributed to things? Like, have you seen this like 3x squared?
Yes.
And then in some form or fashion, then you're like 9x squared? Hello?
Hello.
That's all that's happened here. What about 3x over 4y? Are you still following me here? 9x squared over 16y squared. It goes to everything. And remember, variables are like units. Yes? Okay. But ask a question. And it might just be valid. So then this parses out to be, actually I think it's easier to look at it this side. Let's look at the units that can cancel to clean it up just a bit. Feet squared on top, feet squared on bottom, inch squared on top, inch squared on bottom, centimeter squared on top, centimeter squared on bottom. And then it's just 79, feeling fine, 7.9, excuse me, times 12 squared times 2.54 squared times 1 squared is not anything, over 100 squared. And the only units that are retained, meters squared. Wow. So boys and girls, what's the lesson here? What's the lesson here? What?
Square.
Be specific.
Square all.
Square all conversion factors that require canceling. They require it for canceling. So we're going to look at one instance where it's not necessarily going to work out that way. And I'm going to play it out even though it should be a little actually easier to start from a different path. But what questions have you on this? Jesse has none. You know why?
He's been asleep the whole time.
Because he showed me this part of his head. You know what I mean? He was like, hey, look at this, Mr. Knight. My head. Look, it's got a really cool, I don't know. That's basically what I heard him say as he went like this. Creak, you know? The creaky neck.
Didn't say bend.
That was a pretty bend move on you right there. You literally did your whole name. Do we need to do the math? Do I need to do the math? Are you gonna be okay? Actually, I should for you. This is good little primer on something else. 7.9 times 12 squared in the calculator, which you can do calcu now. You know what I mean? Nobody? You wanna get it? Calcu when? Later. Right? Calcu now.
Calcu then later.
Anyway, not much for dad jokes, I suppose. Neat. Answer 0.7, or excuse me, what I get from the calculator, 0.73393. When writing numbers, you should write to a certain place. Like, when should we stop writing? To a place where you feel comfortable, or like 1 decimal place further than your comfort level. And then go back and assess it to decide what is the actual answer. We'll learn the skill here today. The actual answer is 0.73 meters squared. Final answer. Does anyone have a clue as to why it's 0.73?
Sig Figs.
You got it. That's the reason. That's the reason. I'm gonna teach you my quick and easy, clean and dirty methods for getting it. Yeah.
Dirty ones.
Good stuff. Okay, but what about cubics though? Oh, Olivia.
So that's the final answer.
0.73 square meters. Yeah, that's it. Squared. Square meters.
Do you want to divide it by 100?
No, I did it by 100 squared. So 7.9 square feet. 7.9 square feet is about 0.73 square meters. So think of it in these terms. 9 square feet might associate to a yard, right? Because 3 feet is a yard. I'm just thinking, just mentally in terms of like scope of size. Okay, orders of magnitude. Okay, a yard is less than a meter. So if this is less than 3, or less than 3 square yards. Right. Well, even so, if this is less than 3 square yards, square meters would be less than at an exponential level. It'd be a squared less than, because meters are larger than yards. Okay. But that's just working out through a conundrum there. What if I took volumes, cubics?
Cubic conversion factor?
Yeah. Oh, look at this, Drake. Are you looking at my notes? What do you have right there? You little sneak thief. I see you. All right. Step 1 T chart. 750 milliliters. We want to convert to feet. On your purple blue conversion factor sheet, it has 1 milliliter equals cm cubed. cc's. Oh, cubic centimeters. Cubic cc's. Push 3 cc's of epi. I don't even know if that's enough.
That was unhealthy.
I know you guys know about that. You medical drama bingers, right? No Grey's Anatomy fans?
Yes.
McDreamy or McSteamy? Don't answer that. Huh? Is it really?
Yeah.
But also moment of silence for his character died. Actually, both of them died. So,
What if I wanted to watch it?
what a sad day.
What if I wanted to watch it? I'd probably
Did you say it was his birthday today? Oh, okay. The actor's birthday. Yeah. That was the biggest dumb thing Shonda Rhimes did. Shonda, I'm glad her brand is called Shonda Land, because she literally is taking people on roller coasters for no reason.
Very emotional.
Emotionally and overly woke. Like, I'm awake. I get it. Can you stop? Quit pinching me already. That's all it is. It's a constant emotional pinch. What'd you say? I'm rude?
No, but
She's very rude.
yeah.
Yeah. Just didn't seem like a very nice person. All right, I'll go.
Amen.
So, milliliters. You may not realize this, but you have a conversion factor on your page that takes you to cubic centimeters. And yes, it is a 1-to-1 ratio. So really, you could just just rewrite it in cubic centimeters. But I want to show you how you don't cube everything in this step. So I'm going to leave it. Cubic centimeters to milliliters. Drag down, right? I can go from cubic centimeters. I can't do cubic centimeters. I can do centimeters into inches. And then into feet. Well, I can turn it into feet, not 2 feet. You know what I mean? But have you ever seen, batteries, right? If you ever try to purchase batteries, C batteries are kind of they can create some confusion. You walk into a place and you're like, "Hey, how can I help you?" I just need 2 C batteries. Okay, well, open your eyes; they're right there. You know. Thank you. Matthew was just like stoic.
I didn't get it yet.
I need 2 C batteries. Open your eyes, stupid. You get it?
I get it.
To see them, I need to see them.
I was like, what's a C battery?
Alright, let's keep going. Drag down, centimeters, inches, same method. Ignore the square of the cube for a minute, and then plug in your conversion factors. 2.54, 1 to 1, 1 inch, 12 inches, 1 foot. Before I move on, have I lost anybody yet?
No.
You been lost?
No. At first I was like, why is inches? Feet. I realized we're going from like small to big, so I'm good.
What'd you say, Olivia? Ben? Huh?
I was gonna tell you this, I was gonna ask if you needed the 3, but that's the next step.
Next step, yep.
Don't think ahead.
Anybody else? You can think ahead.
I'm not listening to him.
Alright, so then how do we solve, where does the conundrum appear?
The third.
Oh, no, we have
third
three.
fraction.
Starts happening here. It does not happen here. This will cancel very well with that. This will not cancel with that. So this is where we start our cubing. I cube this, so it will cancel. I cube this, so it will cancel, or because this was cubed. I cube this, so it will cancel that. If I cube this, I must cube the top because a conversion factor is like on either side of an equal sign. Right, a conversion factor as it's originally written. So if I say 12 inches cubed, I need to also cube the other side, or else it's broken. What you do on one side of the equal sign, you do on the other. A la conversion factors, the whole thing. The whole thing gets cubed. Okay?
The whole thing.
Whole thing. The whole thing gets cubed.
Wow.
Yeah. So.
Crazy.
Anyway, 750. You can see what cancels here. You're dividing by 2.54 cubed times 12 cubed, and you'll get your answer, I bet. And it'll be the right one. I'm going to use parentheses this time because typing in a cubed root gets a little compy. That's complicated. Hey, do you know where you would get a calculator that is assigned to you?
Right there.
That's right. Now, I need to assign calculators to those of you who are above 25 or above, 29. I think I have 30 really are good calculators, so I think we all should be good. Yeah, never mind. You just use your calculator number that's assigned to you. The last couple ones are this kind. The other ones are TI 32X2S Pro. I like the 1 through 25. I ordered those specifically, handpicked, and I got them random colors, like some blues, some pinks, dark blue.
Is it better to use that?
But this one is this is my favorite because it has more functionality and it's still pretty user friendly. The whole double button thing, there's certain functions that are doubled up on a button. You just press the button twice to get it. Like we're gonna do log in a little while, and to do log, you have to press the log button with the log on it twice.
We're supposed to get those at the beginning.
Logs.
It'd be great to have them, you know what I mean? But like I haven't told it to you yet, so now I can't have that expectation if you don't know that that's a thing to do.
But we know now.
So now you know you need to get a calculator at the beginning as you walk in, your calculator, and we'll track it down. I'll track it down. If it's missing, let me know immediately so I can blame it on the class before you. Okay? Because it's all about the blame game. Okay. Then we do the math here. Let me finish it. I like to use parentheses because I want to be careful, and I get 0.02649. I just stopped because I want to stop at that point. Cubic feet. Final answer is 0.02. How do I get a different than last time?
Uh-oh.
Oh, no.
You messed up somewhere.
No, I didn't. Oh, no, it's fine. 0.026 cubic feet. Final answer. Why is that the final answer?
Sig Figs.
Because of Sig Figs. Are you there?
I'm there.
Who's lost? If you didn't get this answer, then I would suggest first being careful, more careful. Maybe write, if you type something out, calculate it out, go ahead and write down what you got in the right spot, like above or below the line. and then retype it in. Or use parentheses. You really can't overuse them. So, okay. We good?
What's our first exam gonna be over?
Some of this.
Okay.
Some other stuff that I'm going to do after this.
Oh, gotcha.
And then after that, I'll do some other things, and we'll be over that stuff too. And then perhaps some more things, but we'll see.
It's all on that sheet.
It's all on that sheet. It's like I laid out every day what we're doing. It's sort of like that in some shorthand. Mostly helpful for me, but you can get some from it. Okay. How we feel about that? Are you okay? Are you okay?
What's wrong with the itinerary?
You're not okay?
At least you're on the list.
You're not okay?
I don't know.
What were you saying, dude?
I said at least he was on the list.
So I'll go.
Amen.
What tools do we need for dimensional analysis? We need
T-chart.
T-chart. We need conversion factor. Those are your bare minimum answers. Also, point for you. Hold it. Go.
Oh, yeah.
Oh, yeah.
Although I really was bored of mine, I shouldn't have given you that point. It's sort of like just like a game, sort of. Also, it's going to be point for me if I see your consternation faces.
Maybe we'll constipate.
No, that's several different faces I just put onto mine as fast as I could.
Oh.
If those don't turn into questions, there will be problems later. Okay, it'll be point for me.
You're stupid. Point for me.
A point for me for not asking questions. If you got them, ask them. That's all I'm saying.
Yeah, definitely.
Because I don't want you complaining to over the summer to the rising juniors next year. Because that's what just happens apparently. Is you get these. I'm so confused, and he won't explain to me. You never asked. Did you ever ask if the person who told you the bad things about me? Did you find out if they ever asked any questions?
I've never really heard any bad things.
Last year, all freshmen was just Clark.
It's, of course it's Clark though.
But he was like, it's so hard. And I was like,
Whatever. What you got?
With the cubed feet you had earlier, if you just wanted to get feet, like, is there anything you specifically like?
No, because you have to know like what the length, width, and height. You have to have two of the other measures to be able to know that. If you said it was
Because that's the combination of all three.
yeah, I guess if you said it was a cube,
Oh, yeah, then that one makes sense.
then you could find that you could just cube root it and then find the foot, the length, edge length of one of the sides.
Would you ever want that?
Not in this class. In reality, sure, that's a possibility. In a math, but usually that's in a math class trying to make a real world example. All right, so hey, scientific notation. Do you know it?
Yes.
Okay, well I'm gonna make sure you know it by showing it to you my way. What's the difference between that number and this number?
Absolutely nothing.
No, they look different to me, I would say, Riley.
One's in an
Well,
equation
one's
form,
expanded.
or one's in scientific notation.
One's in standard, one's in
one just has a dope.
So there's a decimal there between the 8 and the 9, and there's not one there.
You move it like 3.
There's 2 zeros after the 8 and the 9, and there aren't here. There's a times 10 to the here, and not over there. Oh, there's a 0, but inside the times 10 to the. Then there's 3. Where does the 3 come from?
Decimal place.
Okay, so that's it. Okay, look, decimal moves is the exponent, always. Times 10 to the is always there. There is always only one number in front of the decimal. What do I mean by one? For our intents and purposes, I mean real numbers. Real numbers, 1 to 9. So 0.4 times 10 to the, not real, not a thing. 4 point whatever times 10 to the, okay. Are you there? Have to have one number in front of the decimal, always a times 10 to the. The decimal moves are the exponent, and then get this. Is that number bigger than 1? Therefore, positive exponent. Above normally indicates positive things, right? Whereas below would indicate negative things. That's where we're going. That's where we're starting with. The above and below line, we're thinking in terms of the number 1. Above 1, positive. Below 1. And then we just treat it as 2 separate activities. So that way you're not like, when I move the decimal to the left, it's a negative positive exponent, move it to the right. We're not going to memorize it like that. We're going to say decimal moves is the exponent. Is the number above 1? Positive. Below 1? Negative. You assign it 2 separate things, and you'll never miss. You'll never miss. Okay, next. Let's follow through here. Look at this. Is that number above 1?
Yeah.
Yes. So it's going to have a positive exponent. How many decimal moves were required?
3.
Of the imaginary decimal. So this number in reality is 5780. Notice no decimal written. We're in this class going to distinguish between an understood or imaginary decimal and an expressed decimal. Let me show you the difference. Imaginary decimal. You don't see it. You don't see it. Ready? Expressed decimal. Just in case you're getting caught up in the semantics. That means the words that I'm saying. Okay. Anyway, notice how many decimal moves were required to make it only have one number in front of the decimal?
3.
3 moves. That's the exponent. We already decided it was positive, so it's positive 3. Hello? Hello. This number, is that below or above 1?
Below.
0.034. Is that above 1 or below 1?
Below 1.
Below, therefore, negative exponent. Always times 10 to the negative exponent. How many decimal moves are required to make it 3.4? 2 decimal moves. Therefore, 2 is the exponent. This is a foolproof plan and way to do it. You may already get scientific notation, but I will eliminate any mistakes you make with it if you follow these rules, which are now posted in pink. They've been posted in pink. Same things over there. Only 1 digit before the decimal. Always times 10 to the bigger than 1, positive exponent. Smaller than 1, negative exponent. The bigger than 1 and less than 1 is its status before you do any adjustments. And let's think of it this way. Why does it become positive? Because when you move the decimal, you shrink it down. Where do you squeeze that bigness to it? You gotta stick the bigness in the exponent, okay? You gotta take that bigness and put it somewhere. Where are you gonna put it? You can't put it on a shelf. You gotta put it in the exponent, okay? Okay, all right.
What's the opposite?
And the opposite is true here. You take the smallness and you stuff the smallness somewhere in the negative exponent. Okay, thanks. Doesn't make a difference. That doesn't add to anything. Yep. Just as long as the value of the number is above or below 1, period. Above or below the value of 1. Right. So that's why I indicate specifically value. Value doesn't care about above or below 0. Like negative, it's just like, okay, negative whatever number, doesn't matter. I'm just going to treat it as a number. I'll keep the negative there in the front, but it doesn't matter for moving the decimal into one number. Scientific notation, are you okay? If you will, look at the periodic table you got out, or you got last week. This one right here. We're going to fill it out today too, hopefully. And then on the back side, there's some scientific notation. Notes. Congratulations. With unbeknownst to you, you took notes on scientific notation. Like I handed them to you and you took them. Right? Took. Versus took. You see what I did there? In a moment, you'll take some more notes on other topics. But for now, this is already on there. You have the notes taken. And then on the right side are non-mandatory practice problems that, let's just say, you're a little bit like, on scientific notation. You can practice the scientific notation, on your own. And I'll let you check yourself against the key at a later time. If you struggle, if you're struggling, if you're like, scientific notation, a little fuzzy, hazy, I'd like some more practice. Okay, I got you set. If you're like, I really don't want more practice, okay, thanks. Okay, it's not required. It's just as needed. Are you there? Okay, good. Next thing, let's do some practice over here. Can you do scientific notation really quick? I'm going to give you about 28 seconds to do the scientific notation for this number and that number. Try my method on for size. I'm sure you've done it your own way, but try my method instead. And just jot that answer down somewhere. Those two answers, sorry. 2 of them. Did you get here? 4.03 times 10 to the 1, 2, 3, 4. Negative 4. Why is it negative?
That's smaller than
That's less than 1. Why is it 4?
4 times.
Took 4 decimal moves to make it look like that. Over here, I can already do the destination. 4.02 times 10 to the
6.
I can already write any of that because this is the destination. Scientific notation is always destined to have one decimal or one number, then a decimal, and then pick up some of the ground after that. Then it's going to have times 10 to the. How many decimal moves does it take to turn this into this?
6.
1, 2, 3, 4, 5, 6. I didn't believe you at first. 6 moves. Is this number 1? Bigger than 1?
Bigger than 1.
So positive, leave it alone, and you're done. Do you want to once again indicate that there's an imaginary decimal that we pretend those moves on to write it here? Otherwise, it must be expressed to have any sort of determination. Hello?
Right.
Okay, cool. That is scientific notation. You're good. You got it. Cool. What about Sig Figs? Maybe you know them, maybe you know a little bit about them, maybe you don't at all. One way or the other, I want you to try A, B, and C on your own. Take about 45 seconds to determine the number of Sig Figs in those numbers of A, B, and C, and then I'm going to reveal the answers one at a time, and we'll deduce some rulesies for thosies. Cool? While you're doing that, I'm also going to pass out dimensional analysis worksheet to practice the converting of other kinds. Then I can see on display, you can demonstrate in full view whether or not you are as confused as you might think you are. You're not. But you might think that you are in order to try to hamstring yourself. Or I don't know, maybe qualify yourself for some sort of begging of sorts. Sort. I owe you gum, y'all.
Yeah, we know.
I didn't give it to you 4 times yesterday or something. Just twice. Riley.
Sorry.
Who do you think you are? Man, I owe you gum twice as often as you should. You're not nobody either. Don't talk about my student like that.
Fair. Yeah, say it's true. Say it was I got it. He's hungry.
Huh? Okay, let's go. 30.1 grams. How many Sig Figs are there?
3.
I'm just giving everyone a chance to say, so don't change your answer just because you're unconfident. It's 3. Because the 3 and the 1 count, they're real. Numbers 1 to 9. And the 0 is between them. So 0 is between 1 to 9. Cool. That's a rule. Cool. How many are here?
4.
I put 4 too.
Oh. 2.
Oh.
Front zeros never count. Front zeros never count. Never. When do they count? They don't. Front zeros don't never count.
Those are nobodies.
If there's, they just don't count.
They're losers.
They're not. They have no embodiment. So,
They're
for more reasons than that, they don't count. And it's okay that they don't count. You know.
Yeah.
All right. The next one. How many are there?
I put 4.
4.
Oh,
Let's try to throw you off the scent. It is 4. Why? Okay, so we said front zeros never count. Back zeros can count when? When there is a decimal there. Back zeros count with a decimal. They're a conditional thing. Back zeros only count with a decimal. Back zeros are candidates to count when, what? When there's a decimal, now they count. Are you there? Front zeros are not even candidates. Back zeros can count with a decimal. Are you there? Everyone say back zeros need a decimal.
Back zero is a decimal.
Okay, so next one.
2.
2. The 5. The back zero is activated by the decimal. What about E?
1.
1. The back zeros, though, where's the decimal?
There's no decimal.
There's no expressed decimal. Imaginary decimals do not activate. Otherwise, we'd have all sorts of other issues. Only expressed decimals can activate. So watch this. 400 pounds. That has 1 sig fig. How can we make 400 pounds have 3 sig figs?
What is decimal?
Express a decimal. How can we make 400 pounds have 2 sig figs? That's it. 4.0 times 10 to the 2. Back zero, activated by a decimal, 4, 2 sig figs. Times 10 to the, never counts, exponents, never count. Are you there? So then we could go, we have 3 there, we can also go 4.00 times 10 to the second. Scientific notation is the easiest, most reliable way to immediately get to sig figs that you need. This is 3, and then 4.000 times 10 to the 2 is 4 sig figs. That's obnoxious, am I right? For sure. We'll get into why in a minute. How many sig figs does F have?
6.
6. Are y'all confused or bored? I can't tell.
I got you.
Say what?
Can we just like go
About this one?
The decimal?
This one?
Yep.
It's a between zero.
I thought it was
It's
like,
between 6 and 8.
I thought it was because even if it was in between zero, if it was like in between the decimal and number after the decimal and numbers after the decimal didn't count.
Is this 0 between real numbers?
Yeah.
Yes. Is this 0 even still? Is this 0 in front of anything? Like, are all the numbers that are real behind it? No, it's got a real number in front of it. So it is not, it's by definition not a front zero, right? So that's why it's not disqualified. It's between sig figs, therefore it counts. Also, it's behind a real number. It's a back zero, it's a behind zero, and there's a decimal. Double reason it counts. Hello?
Hello.
All right, other confusions. Let's go. What you got?
So like, B is only 2 because those zeros come before the real numbers.
Correct. There's no real numbers in front of those zeros. They are front
But
zeros.
if that would have been like 1.0027, it would be 5.
If I put this, 1, 2, 3, 4, 5, 6 would be there if there's a 1 in front of it.
All right, that makes sense.
Okay?
Do you have like steps for like notes that we can?
Yeah, I got one there too. A digit is significant when? I don't know what that first.
We don't know what this is either.
A digit is significant when, i.e., is an SF a significant figure? It is a number 1 through 9. It is between sig figs. Or a decimal is present and the 0 follows a sig fig. Follows, decimal, yes. Follows, no. In front of, no. Decimal and follows, yes. Are you there? Okay, and then some other things you could explore at your own little here. How many sig figs are in this?
26.
3. Times 10 to the. Doesn't matter. Exponents don't matter. They don't count towards the sig figs.
What if it, like, I know this is probably weird, or when I see this, it was like 7.00.
All 3 count. Yep. So, what's the point? What is all this? Like, why do we even care about sig figs? All right, sig figs represents it is a notion or a rule set to align the same precision and accuracy of a number. A number reflects a certain amount of precision and accuracy. Consider 4 versus 4.0 versus 4.00. This one reflects the highest degree of precision and accuracy. Are you with me? Therefore, when we use it as a given, like for conversions or other formulas to come, when we use it, we want to retain that level, that higher level of precision and accuracy throughout the problem. So our answer reflects the same amount of precision and accuracy. Never less, never more. The same. Are you there?
Yeah.
We want all the numbers that the result is or the inputs to reflect the same amount of any steps along the way don't matter. It's only the beginning and the end need to have the same level of precision and accuracy. Are you there? Not as precise or accurate, slightly more, the most precise and accurate. Are you there? So still, this might be like, all right, this feels like another rabbit trail that the they tells us a thing to do. All right, let's say you stand, this won't work. Let's say you have a guinea pig and you put that guinea pig on a scale at home and it registers 4.0 pounds. You bring that guinea pig to school and it registers 4.00 pounds. Then you take it to the science lab and it registers 4.003 pounds. Are you there? We've now, the scale in the science lab reflects the highest degree of accuracy and precision. So our instruments that we can use to measure things, to measure measurables, full circle, you know, those instruments dictate to us how precise and accurate our data is. And then we want to maintain that precision because we went to great lengths to have that equipment be so precise and accurate. We want to maintain that level throughout the course of the problem. Also, it helps things to be repeatable, and we can match up repeatable and methodologies based on results and compare them by precision and accuracy data. Does this make sense? This is the why. Have you ever been explained the why of Sig Figs?
No, I was told this is just how you do it. Just do it.
Go Dogs.
And
See?
like that.
I just raise the precision. You like to enjoy it that way? You don't like it this way? Wow. Okay. I take that as a direct dig against me. It's fine. No, I'll go think about it later and then actually I won't at all.
You just care.
But, no. Be careful using that term, Marky. I care. I just don't care about most of the things y'all have to say that are against me. You know what I mean? The negative.
Fair enough.
I mean, that's, you know.
You don't always care.
No, I pretty much don't care unless I ask. And then even still, there's a percentage where I don't care about that.
So I think I was right.
No, because I don't care. It's too open-ended. I do care. I care about your well-being. And sometimes that's substituted. That's convoluted. What's the word for it? I guess convoluted is the word for it. Oh, conflated. Those are conflated together. When I say I don't care, you're like, oh, you don't care about my well-being or what I have to say about you. No, it's really just the one. I do care about your well-being.
You don't care about our well-being.
No, I do. All right. Are we okay? Are you upset now? Did I hurt your feelings?
My well-being is okay.
I said I do care about your well-being. I think that is okay.
What if it makes it you caring about what I have to say is directly related to my well-being?
I will try to convince you and train you throughout the course of the semester to break that bond. That's something you shouldn't blend together. It should stay separate. As often as you can. I mean, where you draw value from shouldn't be based on certain statements from most human beings. You know what I mean? For the most part, where you draw value from ought to be you are a who, and who you are is who you are, and that's it. That's your who. And that's a foundational, production line from the original who of the I am. You know what I mean? I am who I am. It's kind of a strange conundrum. Was the name of God, but I'll leave it there. Sig Figs. Oh, you know what? You would really be cool. These rules that we just discussed aloud. It'd be really cool if you could have some notes to take on it. So I shall let you take some notes.
That is fine. I
Here,
thought
you
we
can
already
take some
took
notes.
the notes.
And you can
I
take
really
notes.
just wrote it down. and I wrote it sloppy to hurry up, and I was gonna rewrite it when I got home.
Oh man, that's tough.
At least you did it, you know?
Congratulations, you're taking notes. I'm taking a lot of notes today. But don't complain because it's not like spin back. Taking papers. Calm down.
That's not something that.
Oh yeah, don't do anything.
No, that's dimension analysis. Oh,
Thank you.
You're welcome.
I was like, I didn't have my head
All right.
on. I was just like,
All right, so check this out. This, I'll go. Sig Fig practice problems. It gives you some more examples. It walks you through some more rules. The whole point of this, 98% of the time, is to retain whatever the input Sig Figs are. Our answer needs to have the same amount of Sig Figs. Why? To reflect precision and accuracy appropriately. So, generally that's what you do. You go with the lowest number of Sig Figs of the inputs, and then you channel that into your outputs. Now, some of your inputs might be constants. Constants don't matter. Things that are constants like density, they don't count in Sig Figs. The only Sig Figs that count are given inputs that could have been calculated, gathered at a lab station, or measured on a device. Hello? Then, when you take into account Sig Figs with addition, to retain Sig Figs in addition, you don't look at the lowest number of Sig Figs in each one. How many Sig Figs are here? 4. How many are here? 3. How many are here? 3. You don't look at the lowest number and go with that number of Sig Figs in your answer. In addition and subtracting, you line up the decimals, and the one with the fewest decimal places is what you go with. So I'll go 602 is the first decimal place that I stop at. Look after it. 5 rounds the 2 up to a 3. Therefore, final answer 60.3. Some of the other ones, how do I maintain? Where did I get my final answer from? Oh, that was too much already. Let's go back to an earlier problem. Okay, so I said earlier the final answer was 0.026 cubic feet because 750 has 1, 2 Sig Figs. So my answer from this calculated answer, 1, 2, look at the number after and does it round or not. 4, right? 4 or less, let it rest. Or if you're from Northwest, it was 1 to 4, hit the floor.
We didn't do anything weird with that.
If you were from Northwest, if you were from Southwest or East Lawrence, it was 4 or less, let it rest. If you're at Northwest, and if you're at Northwest, 5 to 9, climb to vine. If you're at Southwest or East Lawrence, it was 5 or more, raise the score.
It was always like 5 roll. It's like we learned it on like a hill.
On Northwest? At Northwest? At Southwest? No way.
I learned it on a hill. Like,
They do 5 or more, raise the score, 4 or less, let it rest. Maybe, I'll go. Maybe you guys were the first group of kids to have a different math teacher or something. Because
No, they said climb the vine.
No, they did.
They do.
at Northwest. At Northwest.
I've never heard that in my entire
But at Southwest, 4 or less.
it was a hill.
You never heard the 4 or less, but let it rest? 5 or more, raise the score? Are you Northwest? Raise your hand if you're Northwest. Are you 5 or more or 5 to 9, climb the vine?
Yeah.
Okay, raise your hand if you're Southwest or East Lawrence. 4 or less, let it rest. 5 more, raise the score. None of those? Y'all had it? Okay. I'm telling you, Southwest, they must have had a math teacher change from the year before to this one. Yeah, y'all must have had a different math teacher. Huh?
I don't think this happened.
It happened. No, this is the first group of students I've said these things to, and it's not been a clear distinction between South and North. So anyway, let's keep on. I'll go.
Okay.
Joey, what you got?
So if you're doing like 1 mile to feet, would your answer just be?
Okay, so conversion factors and constants. That's a constant. Those don't play a part.
Like,
You don't look at constants and conversion factors for how many Sig Figs your answer needs to be. Look here. On all these steps of conversion here, I look at 11.6. That's my sole input. This 2.54 and 1, I don't look at for Sig Figs. 1 and 100, I don't look at for Sig Figs because they're constants or conversion factors. Hello?
Hello.
I don't want to even. One immature thing is going on.
The tree having that.
This is from ag class.
She goes, there's a stick in your hand. He goes, what?
All right, I'll go.
Alright.
So check it out. Look here. I got room to make. So the answer I calculated in this particular from first period was 0.007484. My input was 3 Sig Figs. So my answer needs to have 1, 2, 3. Look at the number after. It rounds it down. So 0.00748. Hello?
Hello.
That's all she wrote.
That's all she wrote.
It is all she wrote. That's how we use Sig Figs, Neato, Mosquito, Wilders.
The sayings.
I got them all. All right, so now that thing, that thing you were looking at in scientific notation on the one side, you know what I'm talking about. What's on the other side now? Let me go ahead and point this out. These will be especially helpful, although they actually appear in some form or fashion on docs you already possess. Make sure you have these listed on your dimensional analysis worksheet somewhere, because these will be useful for you. These 3 conversion factors. The rest you would find on here anyway, and you'll even find some of these. But those are the ones you ought to use when you're called upon to do so on the worksheet. What do you need to do on that worksheet?
The work. Sig Figs?
Your answer needs to be in Sig Figs. At least your first attempt. You might get it wrong sometimes. That's okay. You can have T-charts to show your work, or use the slide rule. You need to have at least 1 step of work, or else you'll sacrifice a point or 2 of work credit. The way credit works in this class is that work is 3 points on a relative scale. Work is worth 3 points. Answer number, numerical answer, is worth 1 point, and the units is worth another point. So like in a 5-point problem, you show your work and it's the right work, that's 3 points. You type into your calculator wrong, write the correct unit but the wrong answer, that's 4 out of 5 points.
I like that.
Because I don't want to penalize a calculator error more than once. Plus, showing your work is definitive, is a distinct quality of chemistry, science, the scientific method, and showing your work and proving it is so others can follow in your footsteps and see what you did. Not to give you credit, but to give the work itself credit. To credit the work as creditable, or worthy of following, or worthy of creating of some sort of theory. I have a mirror over here. Shadow. Raleigh shadow. Hold on. Just kidding.
There we go.
There we go. All right, what you got, Olivia?
Can I ask what that second one says? Like
Yep.
the second equation and the second number.
I wanted to say a joke right there. I was going to say it doesn't say anything. It's just like character on the page. But
What
what it reads is 16 ounces equals 1 lbs, pounds.
pounds?
Yeah.
Okay.
No, I
I know
know
that B has a real struggle.
I thought it was like 116. That's not right.
Yeah. Hey, so guess what? It's crazy. My handwriting's off. So, yeah.
Say you swear.
I don't have to say I swear because my yes means yes, my no means no. Thanks, James. It's from the quoting the Bible. All right, you're not James. I don't think you're James. So leave that alone. All right, hey, have you ever seen this before?
Yes.
You know the one on your page too, but where have you seen it before?
Coach Pollard.
Not just where specifically.
It's like there's that
On every test. So this will be the last test that it appears on.
Really?
It's like an homage to Coach Pollock, but also it's to close the book on you needing to have like known the periodic table. You need to know it at this point. So much so that we're going to be done learning how to know it. We're just going to use it from henceforth. We'll use it in this class because it's such a useful tool. So we're going to use it, and you're going to be. And this is going to be our last, yes, hurrah! And I'm going to tell you how it needs to be adjusted because, okay, here's the deal. Physical science sort of, puts a little shiny coat on on some things that aren't a little like false. You know what I mean? So I'm gonna correct the record here in some spots as to what you need to have from this. And this is the first thing where I'm breaking down the wall of physical science and rebuilding correctly the true chemistry. Are you there? All right. So we're gonna fill this out together. It'll be like a key. You memorize how to do it and then show up for the test, and then you get another copy like this with a different element on the bottom, and you answer that from memory, and you'll earn the 5 out of the total points. Nope, and then no worries.
Always been Argon.
Huh?
It's like he never changed it from Argon.
Yes, he did. He had to have.
I don't think he did.
Argon
did.
was like.
He like never changed it.
He has like 2 different,
Yeah, that was over
2 or 3 different.
There was 2 different.
Well, you know how it is. If you're not here, you Argon. I'll see you. You're Argon. You Argon. You know what I mean?
Are they not there anymore?
I don't know.
Anyway, so let's get up some of these things you already know. You sure already know. I'm gonna put a. Oh, well, I got it over here actually. Here's some things you've already done to an extent. I don't. If I put ... right here, that just means element or atomic. I don't care which one you use. Do whatever feels more like home to you. See, whatever feels like home to you. Just tip means something else. So like the first one, element or atomic name. It's the name, but don't just write name. Write element name or atomic name. Whatever feels like home. You know what I mean?
You remember that?
Maybe, are there any non-Pollock classes? Okay. Who'd you have?
Ms. Wood.
Oh, but you use the periodic table all the time. So you'll be fine. And then number 78 here points to the atomic number. The next one points to the
Atomic symbol.
atomic or element symbol. You must include one or the other and not just symbol. That's why I did put the ... there. And then the last one is atomic mass. Nothing new there. I went ahead and started for you the period. Nothing new, nothing changes there. That should be the easiest one. No one should ever miss it. Yet it does get missed from time to time. Wow. Even in your to honors class, the period has been missed by some. Writing them.
I missed the Bollock stand one time.
I don't know. It turns out that students who missed the period part had other downstream other issues. So I don't think it was really they didn't know the period. They had other things. You know what I mean?
Whoa.
They didn't care about school. That's what.
Oh, I thought you were going to.
I wasn't going like they had like an emotional problem and
No, I thought you
anxiety
were
and
like,
something.
you
No,
know,
that
like-
you guys just have to push through that stuff. You know what I mean? This is like I don't care about anything. So anyway, period. Check.
One time I just wrote
Group number. You ready?
like this.
You're kind of ready. You think you're ready? All right. Look. 1, 2. Wow, that was easy so far. 3A and 13. 4A and 14. 5A and 15. 6A and 16. 7A, 17. 8A and 18. Why both? Because y'all learned it as 13, 14, 15, 16, 17, 18. Why the other one? Because 3A, 4A, 5A, those group numbers as A types are easier to see when you're talking about, you know, those outermost, what's it called again? Oh yeah, so you know what I mean. Are you there? Cause like when these form ions, that's another caveat phrase that wasn't necessarily included in your physical science. Physical science, you might learn, hey, these have 3, oh wait, no, I'm talking about the ions they form. Anyway, these have 3 outermost electrons. That's true of every element in this compound. That doesn't mean they all necessarily lose 3, but it is what it is. Or gain 3, excuse me. Well, no, that's lose 3. But still, they have 3 outermost electrons. Hello? How many do they have?
3.
3. You have to look at the ones digit of that other one. It's 3. That's the group it is. It's the A group numbers. Are you there?
Yeah.
Don't believe me, it's on the periodic table. 1A, 2A, 3A. Just, you know?
Hey.
So, anyway, That's group numbers. Check. Here's where the first wall breaker or the second wall breaker is about to come down. That was hopefully going to soften you up. Oxidation number. Here's what do you think oxidation numbers go? How do they go?
+1, +2.
Where? Where are you starting?
On top.
Top. First row. If you write first +1, +2 across those top columns, that is not the oxidation number. That's called the charge. And actually, it's the charge of the ions that would form if they ionized. Are you with me? Hold on. Don't cross off that word, though. We want to do oxidation number. Charge is like +1, +2, +3. It's a statement of how positive or negative it is. Oxidation number, this is going to blow your mind, I promise you. Just bear with me. Oxidation number is very different. It's like this.
Oh my gosh.
Right? 6 plus 6. I know. Let me just give you a moment.
I'm baffled.
Stunning. Trigger. I should have said trigger warning before that. Oh goodness.
That's blasphemy.
Now you're probably all triggered and stuff. And if I cared, I would do something. If I actually cared. Anyway, check it out. That's what you got, Joey.
So like after the 4, wouldn't it be -5 even for the charge? Like or is it?
So yeah, it actually does go 5 minus, 6 minus, 7 minus. There are positive 6 and 6 plus oxidation numbers that exist. So don't be shocked there, but 5 minus, 6 minus, 7 minus, yes, you do have minuses that way as well. Oxidation charges are expression of their distance from zero, basically. Their distance value from zero. Oxidation number is based on their electrons lost or gained. It just has a different mode of expression. I know it doesn't seem that big a difference, but it is different. So what you got?
So concerning the charge, I thought it went +1, +2, +3, plus or minus 4, then minus 3.
And that's where we're about to fill in the other gap here. Instead, what you're going to put is 1 plus, 2 plus, 3 plus, Na. So get this, carbon does not form an ion of any sort. It's covalent or di. It can technically have some ionic tendencies, but it still behaves covalently as a general net effect, even when it seems to behave somewhat like an ion. Silicon, okay, it can sometimes get plus or minus 4, but usually plus 4 only, not even really minus on the other side. Germanium is usually negative. It's usually minus 4. Tin is actually 6 or 2, so rule breaker. It can be 4 or 2. Lead can be 4 or 2. Or it's plus 4 or plus 2. Tin can be plus 4, plus 6, or plus 2. Germanium, but it's mostly negative. Silicon, it's probably the only one that qualifies the whole plus or minus 4 rule. So we just say Na. And we wait for more information. So that's the first plug there. Then we have 3 minus, 2 minus, 1 minus, and 0. Those are oxidation numbers. I don't know what, there is a 5 minus out there, but that's not most common. 3 minus, 2 minus, 1 minus. Those are just for examples. These are reality. This is how reality goes. Okay. Cool. We'll do the other ones tomorrow. Are you okay?
Yes, sir.
Have I just totally broken all the walls of what you hold dear and real?
A little bit.
No, he wouldn't at all. He doesn't. He's fine.
I don't think he cares.
Yeah, probably not a big deal.
He definitely doesn't.
I will say this: you can pack it up and go dogs. Thanks, Rob.
Yeah.
I don't think
Thanks for watching. Tune in next time for another edition of
Night chemistry.